A fire is reported every 2 minutes in Germany. More than 600 people die in fires or the consequences of smoke inhalation every year. Scientists test the fire resistance of various materials and develop tools for very different requirements. Firefighters are to be given new technologies to make their work safer. This is the main fire station of the full-time fire brigade in Cologne. It's the morning roll call. The 24-hour shift is about to begin. Jürgen Ahrens has been working for the fire brigade for more than 20 years. He's at an important hub. He plans current operations and is responsible for long-term strategies. And that means improving the technology, training and infrastructure. Emergency calls come into the central control room. Each of the 11 full-time and 26 volunteer fire brigades in Cologne is responsible for one district. That's to guarantee that firefighters can arrive at a blaze within 8 minutes. But regardless of how good communication may be, valuable time always passes before the firefighters can even start doing their job. It generally only takes 9 minutes in buildings for a smouldering fire to start spreading. But there's a great variation in how fast fire and smoke spread.
If a fire spreads uncontrollably in an area that we consider an escape route, then all the other inhabitants are incredibly at risk from the smoke. This means the people can't save themselves anymore, and the firefighters are massively hampered by the spread of this smoke. If it reaches the next level and the fire spreads as well as the smoke, then the danger increases significantly, and we can no longer rule out that the fire will spread in the building.
In order to prevent such a spread, public buildings like schools and government agencies have strict fire regulations. Since there are often hundreds of people in these buildings at any one time, special escape routes are marked and the buildings are fitted with fire doors. In the Federal Institute for Materials Research and Testing in Berlin, lots of different materials are tested for their fire resistance. Engineer Sascha Horthan and his colleagues get involved when construction materials need to be certified. Today, the prototype of a fire door is being put through some elaborate testing. The requirements for such doors for public buildings are significantly stricter than for the private domain.
Building regulations don't require the doors you fit in your flat or your house to exhibit any increased fire resistance properties. That means that if you buy a door in a hardware shop, it won't have any kind of fire resistance.
In the fire room, they test the heat resistance of the door. Sensors measure the temperature changes. These tests determine whether such doors can be used in public buildings. The wooden door has 2 wings and is built into a glass wall. The wood and the glass have to survive temperatures of up to 1,000 degrees for 30 minutes in this test. The temperature development is monitored in the control room. It's crucial that the door's exterior temperature doesn't rise above 200 degrees, because otherwise the fire can get through.
Fertig, los.
After the fire sources are ignited, the chamber is immediately very hot. So far, the fumes that are escaping are considered normal at the critical locations. But the infrared camera reveals that one critical spot has reached 90 degrees after just a few minutes. The heat on the upper door frame is going up. A laser measures deformations on the exterior wall. That shouldn't happen. In addition, a prepared cotton pad is used to examine the escaping heat. If the cotton ignites within 10 seconds, the door will fail. While the door is undergoing further testing, we're heading back to Cologne. Jürgen Ahrens and his colleagues also deal with novel materials in house fires. Recently, they've had to deal with more and more solar panels. What happens when houses with such panels catch fire? Photovoltaic roofs are under high DC voltage, which can be dangerous for firefighters.
We've been using these solar panels to generate electricity for years, but this technology is an issue for fire brigades too. Maybe it's best explained by saying that the suppliers provide too little education about the technology, which then leads to uncertainties in their use.
One case in point is in Schwerinsdorf in northwest Germany. Several fire engines from the voluntary fire brigade are called out. Even though the flames have already got through the roof, it takes the firefighters a long time before they can start putting out the fire. There are solar panels on the roof. The firefighters are unsure. When they finally start extinguishing the fire, it's too late. They let the house burn down in a controlled manner. Full-time fire brigades have long been trained in how to extinguish fires involving solar panels. Jürgen Ahrens is aware that not all of the million-plus firefighters in Germany possess this knowledge. There's a lack of education. Extant guidelines for extinguishing solar panels are based on recommendations. For that reason, testing agency TÜV Rheinland in Cologne is conducting special tests for the first time today. Jürgen Ahrens has agreed to meet Florian Reil, an electrical engineer from TÜV. He's set up tests to simulate how electricity flows in solar panels. Once connected in series, he quickly reaches 1,000 volts of direct current. Direct current behaves differently from alternating current.
The differences come from the fact that the frequencies can cause cardiac arrhythmia, and there's the high voltage. With a direct current, I can be sure of burns. There are other influences that can affect the whole body and put the heart under pressure too.
An initial test, the protective clothing worn by firefighters is put in contact with parts of the solar panels that carry the direct current. It's a common scenario when firefighters have to go into the cellar of a building.
We can't tell how the power from the solar panels is being carried. These cables go all over the building, and if the solar panels haven't been installed properly, there's no clear clue for us which bits carry the electricity.
Indeed, the standard switch with which the current from the solar panels can be switched off is missing. The scientists want to find out whether the firefighters' clothing will protect them if they come into contact with such cables. The test reveals that the gloves, jacket and shoes are fine, but only when the clothes aren't soaking wet. The second simulation, the firefighters are to extinguish solar panels, just as in the case of the house fire we saw earlier. The whirling water reduces the current with every metre of distance, or at least it does with AC. Firefighters know that, but it's never really actually been tested with DC. Reliable figures are needed. The distance between the solar panels and the steel pipes just a metre. The panels are carrying 1,000 volts. More than 120 volts is considered life-threatening. The results reveal that the current falls off with increasing distance in a linear fashion. It's almost the same as with an alternating current. In other words, if the firefighters are far enough away, they're safe. These days, water alone is being used less and less to put out fires. For that reason, a frequently used extinguishing agent is being tested too. An addition of just 0.5% significantly increases the extinguishing power.
This extinguishing agent is added to water. It reduces the surface tension of the water, which allows it to penetrate the burning material better. That gives the water a better extinguishing power, and it also gives us a decreased likelihood of reignitions. That's why we add this agent.
The scientists think that the alkaline agent will increase the water's conductivity. That would mean that the firefighters would need to be further away in order to put out a fire safely. But the tests conducted by TÜV Rheinland show this extinguishing agent behaves like water. The exact test results will be published soon. That would give firefighters reliable data about safe distances. The knowledge obtained today will help firefighters to act correctly on the job. The Federal Institute for Materials Research and Testing only allows clear results too. Will the fire door pass the test? The interior temperature has gone up to more than 700 degrees and more smoke is developing.
Now we have a massive passage of hot gases through this opening. A rapid increase in the temperature here.
After 25 minutes, the infrared camera indicates more than 200 degrees. A critical point has been reached. The door has bent inwards because of the negative pressure inside. A further cotton wool test is unsatisfactory. The cotton wool is glowing.
We got above 200, which means the failure criterion has been reached. The door doesn't pass.
The negative pressure in the fire chamber is significantly higher further up than at the bottom, since heat rises and more oxygen is consumed there. In real fires in buildings, doors have to withstand this pressure in order to offer real protection. This door didn't manage that. It's not clear yet why exactly